Let's get started. Questions on the homework? Yeah, we'll do it real quick. Which one? 11? Let's give it a go and see what happens. Excellent. All right, on number 11. To solve the equation. So, I'm going to take e to the x squared equals e to the 7x minus 12. Since the bases are equal, did I start recording?
Yeah.
Okay. Since the bases are equal, what can you do with the exponents? Set them equal. So now when does x squared equals 7x minus 12? Quadratic. Swing everything to the left because I like a positive a. Minus 7x plus 12 equals 0. Yeah, you can do the quadratic or you can factor it. X minus 4, x minus 3. So x equals 4 or 3. Now, having said that, what's the domain of the exponential function? Thank you. It is all real, so I don't have to worry about any x values putting it in there, so it always works. Okay, so all these work, and we're in good shape. Fantastic. Anything else? We didn't get that far, did we?
We went to 15, you said.
Sure, we can give it a go. I mean, we were going to go to 13 or 15.
No, we didn't find those yet. They're different sections.
You said try 15.
Yeah, I said try 15. Oh, yeah. That one you can do, but we'll do a homework problem just to check it out. Or notes, okay? Anything else? I think you will need possibly need your calculators today. I'm going to go ahead and get mine all booted up. I just lost something, froze. There we go. All right, here we go. Running a bit choppy. It is a little tired. It's not running real well. We did a continuous. We did that one.
You were on number 13. We hadn't done any yet.
And we just solved the base. And we're getting ready to do that one?
Yep.
All right. Find the zeros of this function. So to do that, well, you can set it equal, obviously. And the first thing is, you want to always see if there's the 3 tiny letters GCF. That's how you want to try to factor some things at first. Well, there's obviously an x in common with both of them. There's an e to the negative x in common with both of them. So I can factor those out. An x and an e to the negative x. That leaves me with what? Left over inside the parentheses. Yeah, a negative x in the first term, and what about the second one? Plus 2. Now you take a look at each factor. That's what factors are. They multiply together to give you an expression. This is a factor, this is a factor, and that's a factor. Or you have 3 factors to look at. What will the first factor equal 0? Yeah, x equals 0. So there's one of your solutions. What will the second factor equal 0? Well, e to the x looks like this with a horizontal asymptote at 0. E to the negative x flips over the y-axis. So where will this graph equal 0? Well, in other words, where will this graph cross the x-axis? It won't. There's a horizontal asymptote there. So the second factor does not yield any solutions for this problem. That brings us to the third factor. When will it equal 0? At positive 2. Okay? So, those are the 2 solutions, 0 and 2. Not bad at all. Remember, exponential functions won't equal 0 because there's a horizontal asymptote there. Now, if I would have had a plus c or something, I could have checked it out. But in that case, nope, we're good. Moving on, ready? Law of growth. We talked about this yesterday. Growth means f of x is what? Increasing, right? Decay means f of x is decreasing. So, on this, you're going to notice some similarities between the a equals pe to the rt. It's been replaced. A equals pe to the rt. There are some similarities. What do you think this q of t is going to be? The ending amount. The total amount you're left with at the end. What do you think this equation, q sub 0 means? What? Initial amount. Initial amount. E is a number, correct? R, the growth rate or decay. And this is the difference between the two equations. The A equals PE to the RT is a business model. T is always in what? Years. T is always in years. In a science model, T can be minutes, it can be days, it can be seconds, it can be years. It can change based on the problem. So in this case, T is problem specific. That is different between the business model. We were just talking about that last night in the office, how the scientific model and the business model differ between exponential functions. Some kid was asking a question about it, just couldn't understand how you have a difference. PERT on a mutual fund, fantastic. All right, so that's the growth and decay. You have to figure out, oh, by the way, your initial amount, FYI, I just assumed everybody knew it. That's usually when T equals 0. The initial amount, that's usually when T equals 0. But I learned, after going through this with another class, I need to say that. Okay? How do you know? All right. Oh, look at this. In 1985, wait a minute. 1985 is how many years ago? 10, 15 years ago? Is that right?
Yeah.
So everybody was born then, right?
No, 85.
25 years ago. None of you were born yet but me. Ah, in 1985? Wait a minute, how many years ago is that from 1985 to now? 25. Well, yeah, if you go to the year 2015. All right, so anyway, you're starting in 1985, and the population was 766. Remember, I said that's when T equals 0. So 1985, T equals 0. And this is your beginning amount, Q of 0. I never use Q except for this problem, except for this book, except for this section. Growing continuously at a rate of 1.82%. Very good. So R equals 0.0182. Assuming that this rapid growth rate continues, estimate the population in the year 2015. Minus 1985. T equals, what do we say it equaled? 30. Estimate the population. That means you're looking for the ending amount. So when you read it, you need to read it for understanding and comprehension. When I read something, I read it very, very slowly because I don't like to reread. I got tired of rereading in college, so now I just read things slowly, but I usually don't forget things that I read. So, nice. What'd you get?
A really big number.
No, it can't be that big. Well, I'm not going to put 700, I'm just going to put 766, right? Or are you going to put 766 with the 6 zeros? What do you want to do?
766.
I was going to put 766. Okay? And then what goes next? The E, right? I'm going to use the one with the caret button. And then it's going to go to 0.0182 times what? 30. Fantastic. Enter.
1,300,000.
So this is in millions, correct?
Well,
So this is in millions? Yeah, so you could like move the decimal 1, 2, 3, 4, you know. You can say that is your answer. So it'd actually be 1,322,371,732.
is it like that because it's not money?
Right. Okay. So you can write your answer a variety of ways. Some people write 1.3 billion. That's fine. Some people write 1,322 million. Okay? It is a lot of people. The question is, do resources start becoming a problem at that population rate? Yep.
Why is people?
Oh, because that was my initial amount. I don't want people putting in 1985. I'm starting my graph at 0 with the y-intercept of 766. So it looks something like this. At 0, I have 766. And then it takes off like that. Okay? Anything else? I like these problems a lot. You're going to see a lot of these on your quiz before the final. Okay?
Question on the final. If we take it and we do bad,
Only if you're certain people will I count against you. You're not one of those people. All right.
What about me?
I'll decide that later. The length in centimeters of many common commercial fish T years old can be approximated by the von Bert one. See, if I was a science guy, I'd know that name just like that, but I don't. By the equation of the form A equals, let's see, F of T equals A times 1 minus B e to the KT. All right. T is in years. I think we're in good shape. This is a length function. Okay, so we're in good shape. So this is nothing more than a calculator exercise on part A. Estimate the length of a 10-year-old halibut. Can you punch this out correctly on your calculator? So go ahead and get your calculators out, please, and let's give it a go. It says A is 200. 1 minus B, 0.956. E to the K, 0.18. Then T is going to be what? 10 times 10. And again, it's just, can you punch this out correctly? So, let's give it a whirl. 200. Parentheses. 1 minus 0.956. Second, E.
0.4.
0.18 times 10. What's a negative?
I got
It's supposed to be negative K.
Negative K in the problem?
Yeah.
Oh,
Negative sign.
negative K. Like that? Interesting. They read the problem in the textbook.
Why is it supposed to be negative?
In the textbook, it says that.
Yep. It does say that.
Second, inserts negative. I put in 2 negatives just to be safe. Delete. Enter. 168.4 centimeters. 0.18. View. So I got 168.4 centimeters. Does that look right? Once we adjust the equation for the typo, looks pretty good. All right. No, I just round to the nearest tenth. Right. On the one with money, you go to the nearest hundreds. On the last one, there weren't any decimals because we used them all as whole numbers. because it was written in scientific notation, because we had millions, so we just moved the decimal back 6 places. I don't know, it's pretty easy going, but they'll probably let you know for sure how many decimal places. All right? So far, so good? Excellent. Moving on. Didn't we already do this one? Oh, there's a negative right here. Use the graph to find the estimate of the maximal. What's the biggest a fish is going to get if it's a halibut? Oh, it could be like huge, like 18 footers. Like Jaws. Oh, wait a minute. How do you know there's going to be a maximum?
Increasing. Or
Because is a popular answer. What's decreasing?
size. So
As the fish gets bigger, it's getting smaller.
like what?
As the fish is getting older, it's getting smaller.
I don't know.
There's a what?
It's
The
a
maximum it obviously has to be.
Man, all right, it obviously has to be, but how do you know whether there's going to be? Because is a popular answer. They've changed it from cuz to because to enunciate
it's
the
never
because.
cross the x-axis, right?
Right, it's never going to cross the x-axis
Well, how do you know that?
because it's an exponential equation. We know there's a horizontal axis right here.
So it's going to eventually have to stop.
No, this says it's going to go on forever.
Yeah, but we're not going to be able to measure it.
Yeah? Fish cannot live forever. That's true, but I'm looking for something a little bit more mathematical.
There's a negative, that's what
There's a negative, so it's flipped where? Look at Drury's almost paying attention.
x-axis.
Over the x-axis. There's actually 2 negatives. One, this negative flips it where? Over the y-axis. So now I have this. And this negative flips it over what? The x-axis. So it flips it this way. And now, what does this number out in front do right here? What does this part do when you add something to it? It's a vertical shift, so it's going to raise it up. So the equation is affected, so it looks something like this. The 2 negatives give you the fact there's going to be a maximum. The only way to find that is graph it out and take a look. We already know on our last question, what did we get for our last question? No, on part A, what did we get? 168.4 centimeters. So our Y window, we're going to go up to at least 168. All right, go ahead and punch it out.
X or the y?
Well, the first negative up here in the exponent, that flipped it over the y-axis. And then the negative out in front flipped it over the x-axis. Oh, no, it's in your book. And then this number shifts it up. Okay? All right. 200 minus 0.956. Clear. 200 minus 0.956, second E, to the negative. Oh, I forgot the parentheses. Second insert, parentheses, 1. Got it? And then, well, not a graph, I can't second and enter, can I? Oh, it worked? Oh, interesting. I've never done that before on a graph. Wait a minute, negative, what was the constant? 0.18, something like that? 0.18 times x. Is it 0.018 or 0.18? All right. So, I got on my window. My y's have to go up to at least 180. Okay. And then my x's, I want a 10-year-old. Let's see if there's a 20-year-old halibut out there. No, not yet. And I close it off. Does that equation look all right now? Times 10? Actually, I'm using x as my variable because I want to calculate the length for every year of age. For my window, I just go 0 to 20 and 0 to 180.
Would you want to change your Y scale because you got such a 180?
I could. I'll just see a bunch of dots. I mean, I could make them all 20s. And graph. There's our negative, and I didn't go quite high enough, so it's past 200. It looks like I didn't go out far enough. So I'll just, it's an easy fix. I go to 300. A 300 centimeter halibut. 300 is a bit extreme. I can. I still didn't go far enough.
There, I got mine. It's like,
I'm trying to think.
0 to 4? Oh, I got 0 to 4. I want 0 to 40. There we go. Well, I had, but something happened. Graph. There we go.
Yeah, mine's I keep putting it later. It's negative 300 for the minimum,
I
right?
got 309.
So around 310. Here's my window. Check your minimums and your maximums. Make sure they are smaller and bigger.
If mine look like this,
I don't know.
I don't know if my windows are all messed up.
Well, yours won't look exactly like mine unless you have the same window. Yeah, you got an answer. Did you get the right answer?
Thanks.
Yeah, I went to 300 instead of 200.
Oh, okay.
That's fine.
I don't know what.
Level that out.
Yeah, levels out.
So we go to second, calculate max.
No. Second, calculate value at 250. Oh, that's too much.
Try 201.
No, I went to 40. So I'm going to go to 35. A 35-year-old halibut will be 199.64 centimeters. What's your... Okay. 200. 1 minus 9. You forgot the x. So, looks like the maximum is going to be 200, isn't it? 200 centimeters. I like that. So, the two negatives make it into a maximum question that you could use calculate max, but we've never done it on a problem like that, and that's a little different. How do I know there's what? Oh, I just looked at my graph and said, oh, somewhere over here looks like there's a maximum. And I said 200 would be a safe answer. Okay.
Did you not calculate a maximum of mine?
You could,
When it
if you know calculus. Yeah, sure. In calculus, you can calculate everything.
That's why it's called the calculus.
Sure. Sketch the graph of the equation. This one's not going to be difficult. The negative is going to flip it over what? All right, here's the e to the x. Looks like this.
Hey, it works. It says at 40.
Good. What's the negative going to do? Flip it over the what? Yeah, it flips over the y-axis, doesn't it? And then what's the 1,000 going to do since it's in the parentheses? Is it going to stretch it this way, or is it going to stretch it, pull it apart?
Over the x's.
It's going to squish it. Yeah, so horizontal
Compression.
compression. So this one is going to be 1,000 times closer to the axis than this one. That's going to be pretty small, isn't it? This one's going to be 1,000 times closer to the y-axis than the blue line. That's pretty tight, isn't it? In fact, it'll be so tight, you probably won't even be able to see it on your graph. dx, negative 1,000, x. Oh, I need to go zoom standard. On breaks it, zoom 6, finishes it off, and it's 1,000 times closer, so I can't even see it. Head over something there? I don't know. Second, calculate value at 0. 1. And then watch this. If I press this back arrow, I'll go to trace. It's tracing the graph and it's hard to see. See, it's like way up there already. Interesting. You can change your window to see it, but that's going to be a tough one to see. The blue line is the original graph. Then the red line is the result of the changes. Right. Negative over the y-axis because it's inside the parentheses. And 1,000 makes it closer to the y-axis. All right. Approximate. How do you think you approximate the real root on here? You look pretty smart. What do I always tell you to do when you don't know what to do? Graph it out. How are you going to graph this one out? Move everything to one side. You want to work with a negative E or a positive E?
Positive.
I always like positive E's.
You don't like to be negative.
No, I don't like to be a negative. So, let's graph it out and give it a shot. Y equals, clear. View. All right, type it in. E to the 3x, close it off, plus 2x, minus 5. I'll just go to Zoom Standard first. Give it a whirl. Oh, I got an answer. You think there's more than one? Why do you think so, Miss Jones? You can't use that as a reason then. You have to have a mathematical fact.
What?
Why do you think there's one answer?
Because,
Oh, that's not an answer. That's a junior high response. This is high school. Next semester will be college. We need better answers.
how's the x-axis?
Well, this is what type of function, this e to the 3x? No, that's called an exponential function. The variable's in the exponent, see? Exponential functions look like what? So, do you think it's ever going to bend and come back down just for fun? Probably not. This is a linear function, right? It's just going to, it's not going to bend and come back down and have any fun. So, there's probably going to be one answer.
So we can just calculate the 0.
Yeah, second, calculate the 0. I still don't know how to do that. Well, practice makes perfect. Hey, I'm good. Left bound, 0's on the left side of that, enter. Right bound, let's go 6.
About a half.
And then 1.
0.467.
Yeah, I would probably say 4 decimal places when it says approximate. 5 decimal places? 4 is fine. 0.4675. Okay,
Not bad.
excellent. I like that. That's a good one. How far are we on the homework?
52.
All right, let's see. Let's do this last one. Do I have one more after this?
You said we were going to go pretty far today.
Yep, we are. We're going to finish it up right here. How do you think you're going to do this last problem? It says graph f and g on the same coordinate plane. Estimate the solutions of the equation f of x equals g of x. How do you think I would do it? Or how do you think you should do it? What's the most efficient way of doing it? Yeah.
If they're equal to each other and like f of x equal to g of x, can you just take their solution?
No?
Graph it.
How would you graph it? Huh? You can use y1 and y2. You can do that. Or, this way you're using y1 and y2, and which button are you going to use to find the answer? Intersect. The other way of doing it is to do what? Well, they are together, but yeah, you can set it equal to 0. So you can take f of x minus g of x, set equals 0. Which button would you use? What? Right, you're looking for the zeros, so you use the 0 button. And for guesses, you can use the value button. So here you have one equation to enter, and you can use 0. Here you have 2 equations to enter, and you're going to use the intersect. Why am I a fan of this?
For
Well, for one, here you're looking for the y values. I don't know how big the window has to be to see the y values. Here, where's the y values going to equal? 0. So I always have to look at the x-axis. I don't have to worry about how high or how low to go. So here I'm looking at the x-axis on this approach. Here I'm looking at, well, I don't know, my window has to be adjusted. That's why I like the second one. That's how I'm going to do it. You can do it either way. I'm going to do it this way. Let's see, 0.3 second e to the x. I got two of them in there. E to the x. Close it off. Minus, I like to use parentheses, x cubed minus x. X caret 3 minus x. Punch it out. Give it a whirl. I'm going to go to zoom 6. Zoom 6. We got 1, 2, 3. Ooh. Why would it look like that? Oh, 4. Nice. I like that little surprise at the end. Why does it have this characteristic? Why does it look like that snake right there?
The cubic.
The cubic's in there, isn't it? And then it tails off forever. That's the exponential influence. So it looks like I have 4 answers. All right, let's do this efficiently. Who's going to take the one on the left? Somebody's going to have to find the one on the left first. Who's going to do that? Drew, find the one on the left. Who's going to find the one right here on the right? Or the second one? Good. Who wants to find the third one from the left?
Yeah, mine won't get a little hump there.
Oh, I'm sorry, you didn't type it in right. Fix it? Oh, you want me to come over and fix it for you?
You know, like,
I can help.
I did it right.
I don't help, I just do it.
No, I got it.
I don't think so. You forgot your minus sign, Ms. Jones.
Oh, thank you.
This one right here.
How do you do insert just so you don't have to delete everything?
INS. Yep.
Negative
-0.934 889. Okay. And what's the next one going to be? -0.2493. Good. The third one. Who's that? Oh, that's you, Colin. And who got the fourth one? Yep. Yeah. 7.03. Thank you. 7.2. Well, Ms. Jones. 7.4. Well, go ahead. What is it?
1.4.
1.4. Thank you.
Stop. Oh.
All right. So there's our 4 answers. Fantastic. Excellent.
Very fun.
It was. It doesn't get any better than that. How far is this? Page what?
Oh, what number was that?
312.
312?
Yeah.
So I go to 51? Oh, no. 13, 15, 15 to 51. Right? Sounds good, right? Sounds like a plan. We got 15 minutes left? 20 minutes? 10?
You're always off when you.
I don't know why I'm off.
It was this time.
It did?
Yeah, finally.
Good. Excellent. I don't know why I'm off so much in this class. Oh, well. Oh, I know why. Never mind. I was going to do not a brain break, but I was going to do a 10 for 10.